Imagine a bustling, hidden world, teeming with life. Now imagine scooping up a piece of that world and sealing it inside a glass jar. What would happen if we take a simple jar, fill it with water from a local pond, and seal it shut for 100 days? We embark on a remarkable journey. This is not just a jar of murky water. It is a miniature ecosystem, a tiny planet all on its own. Inside, we have trapped a whole community of living things. There are tiny plants, microscopic animals, and countless invisible bacteria. We have also sealed in a limited supply of everything they need to live: water, nutrients from the mud, and a small pocket of air. This simple experiment will show us the powerful forces of life, death, and change, right before our very eyes. On the very first day, the jar is a cloudy collection of everything we scooped from the pond. A scoop of sludgy mud settles at the bottom, rich with decaying leaves and hidden treasures. Specks of green float suspended in the water column. These are algae, the tiny plants that will become so important. If we look very closely, we might see a small water snail inching its way across the glass, or a tiny wriggling worm burrowing into the sediment. The water itself is a brownish green, a sign of the rich organic matter dissolved within it. This is our starting point, a snapshot of a complex community, captured and isolated from the vastness of the pond from which it came. The stage is set for a drama that will unfold over the next 100 days. The key to this entire process is sunlight. By placing our jar on a windowsill where it can receive daylight, we are providing the energy that will power this entire world. The tiny plants and algae inside are like solar panels. They will use a process called photosynthesis to turn sunlight, water, and carbon dioxide into food and oxygen. This is the very foundation of the food web within our jar. Without sunlight, our little world would quickly run out of energy, and all life would cease. The small pocket of air trapped at the top of the jar is also crucial. It contains oxygen, which most of the animals will need to breathe, and carbon dioxide, which the plants need for their growth. It is a delicate balance from the very start. The jar is now a closed system. Nothing can get in, and nothing can get out, except for the light and warmth from the sun. This is what makes the experiment so fascinating. The inhabitants of our jar must survive with only the resources they have. They must adapt to changing conditions, compete for food and space, and recycle everything to survive. It is a story of survival on a miniature scale, a perfect reflection of the great cycles of life and death that happen all over our planet. What seems like just a jar of pond water is about to become a theater for one of nature's most fundamental stories. Let us watch and see what happens next. During the first 7 days, our jar of pond water becomes a hive of activity. It is a tiny, bustling metropolis, full of creatures exploring their new, glassy boundaries. With plenty of sunlight, the algae begin to multiply rapidly. These microscopic plants start to coat the inside of the glass with a faint green film, and the water itself may become a slightly brighter shade of green. This is the first bloom of life, fueled by the nutrients from the pond mud and the energy from the sun. The algae are producing oxygen, making the water rich for the tiny animals that live there. It is a time of abundance, a golden age for the jar's inhabitants. If you were to look through a magnifying glass, you would see an incredible world of microscopic wonders. Tiny, darting creatures called copepods and daphnia, often known as water fleas, swim through the water in jerky motions. They are grazers, feeding hungrily on the booming algae population. On the sediment floor, minuscule worms wriggle and burrow, sifting through the mud for bits of food. You might even spot an amoeba, a shape-shifting blob, slowly extending its body to engulf a smaller organism. At this stage, the jar is a complex food web in action. The plants produce, the grazers eat the plants, and perhaps a slightly larger predator, like a dragonfly nymph that was accidentally scooped up, hunts the grazers. The water remains relatively clear apart from the green tint of the algae. A faint, earthy smell might be noticeable if you were to open the jar, a scent of damp soil and fresh pond life. This is the smell of a healthy, active aquatic ecosystem. The balance between producers, the algae, and consumers, the animals, is, for now, in harmony. There is enough food to go around, and the waste produced by the animals is being broken down by bacteria, releasing nutrients back into the water for the algae to use. It is a perfect, self-sustaining cycle, a little world operating in equilibrium. However, this flurry of activity cannot last. The resources inside the jar are finite. The initial boom in population is using up the dissolved nutrients in the water at a rapid pace. The animals are consuming oxygen as they breathe, and while the algae are producing more, a delicate tipping point is approaching. Every creature is reproducing, adding to the population, and increasing the demand on the limited supplies within their glass universe. This period of prosperity is exciting to watch, but it is the calm before the storm. The very success of the community in these first few days is setting the stage for a dramatic change that is just around the corner. As we enter the second and third weeks, a dramatic and somber change begins to take place within our sealed world. The vibrant activity of the first week slows down, and the jar enters a period often called the Great Dying. The massive population boom has exhausted the initial supply of nutrients in the water. The algae, which once thrived, now begin to die off in vast numbers. They have consumed all the available food, and the community can no longer support its size. The water, once a lively green, starts to become cloudy and murky, filled with the decaying remains of dead algae and other microorganisms. This is a stark reminder that no population can grow forever without consequences. The animals that depended on the algae for food now face a crisis. The Daphnia and copepods, which swarmed the jar just a week ago, begin to disappear. With their primary food source gone, they starve. Many of the larger, more complex organisms, like any small snails or insect larvae, also cannot survive the changing conditions. They require a lot of oxygen, but the process of decay consumes vast amounts of it. As bacteria work to break down the dead algae in animals, they use up the oxygen in the water, creating a toxic environment for any creature with gills or a need for respiration. The jar's metropolis has become a ghost town. A distinct and unpleasant smell would now be emanating from the jar if we were to unseal it. The sweet, earthy smell of the pond is replaced by a foul odor, like rotten eggs or swamp gas. This is the smell of decomposition happening without enough oxygen. It is caused by specific types of bacteria that thrive in low oxygen conditions, releasing sulfur compounds as they break down organic matter. The color of the water changes too, shifting from green to a murky grayish-brown. The bottom of the jar becomes covered in a thick layer of dark, decaying sludge, the final resting place of the once thriving community. This phase, while grim, is a crucial and entirely natural part of the cycle. It is nature's way of cleaning up and recycling. The death of the many provides the raw materials for the few who will survive and for the new life that will eventually emerge. Every organism that dies releases its stored nutrients back into the system. These nutrients are locked away in their bodies, and it is the job of the decomposers to unlock them. The Great Dying is not the end of the story for the jar. It is a violent, necessary transition. It paves the way for a different kind of world to be built from the ashes of the old one. Following the Great Crash, a new empire rises from the depths of the jar. This is the age of the decomposers. In weeks 4 and 5, the most visible life forms are the bacteria and fungi that have been working all along, but now they are dominant. The water may still be cloudy, but the scene is one of furious, albeit microscopic activity. These organisms are the cleanup crew of our ecosystem. They are feasting on the thick layer of sludge, the dead algae, the deceased water fleas, and any other organism that did not survive the crash. Their population explodes as they work tirelessly to break down all this rich organic material. These decomposers are essential for the future of the jar. As they consume the dead matter, they perform a kind of magic. They take the complex materials that made up the bodies of the plants and animals and break them down into simple, basic nutrients. Things like nitrates and phosphates, which are essential for plant growth, are released back into the water. This process is the great recycling engine of nature. Without decomposers, all these valuable nutrients would remain locked away forever, and no new life could grow. The foul smell may begin to lessen slightly during this period, as different types of bacteria take over. Looking closely at the sediment at the bottom, you might see new signs of life. Wispy, white threads of fungus might spread across the decaying leaves, looking like a fine cobweb. These fungi are experts at breaking down the tough, woody parts of plants that bacteria find difficult to digest. The water itself, though still murky, might start to show subtle changes. As the bacteria finish their work, they too will begin to die off, their job complete. This causes some of the cloudiness to slowly settle, forming a finer, darker layer of sediment at the very bottom of the jar. The great feast is coming to an end. While most of the larger animals are gone, some incredibly tough microorganisms may have survived. Certain types of protozoa and single-celled organisms can form protective cysts, like a suit of armor, allowing them to wait out the bad conditions. They lie dormant in the mud, waiting for the oxygen levels to rise and for a food source to return. This period is a quiet, patient one. The frantic energy of the first weeks is gone, replaced by a slow, methodical process of renewal. The decomposers are resetting the stage, preparing the jar for the next act in its long and dramatic play. As our jar passes the halfway point of its journey, a new order begins to establish itself. The frantic work of the decomposers has released a fresh supply of nutrients into the water, and the conditions are now ripe for a second bloom of life. However, this bloom is different from the first. The species that thrive now are not the same ones that dominated the initial weeks. These are the survivors, the specialists who are perfectly adapted to the unique conditions of our closed-off world. Certain types of algae, perhaps different species that are better at surviving in lower light or with different nutrients, start to grow. The water begins to clear, and a new, more stable green hue appears. With the return of the algae comes the return of the grazers. But again, these are not the same creatures we saw at the start. The delicate Daphnia are likely gone for good. In their place, we might see tougher, more resilient organisms. Perhaps tiny circular creatures called ostracods, also known as seed shrimp, emerge from the sediment. They are excellent scavengers, able to eat not only algae but also the leftover decaying matter, making them perfectly suited for this new environment. Small, hardy worms, which can tolerate low oxygen levels, may become more visible as they sift through the processed mud, now rich with bacterial remains. This new community is far less diverse than the original one. The complex food web has been simplified dramatically. There are producers like the new algae, primary consumers such as the ostracods and worms, and the ever-present decomposers, bacteria. The larger predators are gone. What is left is a streamlined, efficient system. The population sizes are much smaller and more stable. There are no more dramatic booms and busts. Instead, the growth of the algae is slow and steady, and the grazers that feed on them keep their numbers in check. It is a system that has learned from the chaos of the past. The appearance of the jar has changed once more. The water is noticeably clearer than it was during the crash, though perhaps not as clear as day one. A healthy layer of green algae coats the sides of the jar, and any surviving aquatic plants may show new, slow growth. A few empty snail shells on the surface of the sediment serve as tombstones, memorials to the inhabitants that did not make it. This new ecosystem is a testament to the resilience of life. It demonstrates how, even after a catastrophic event, life finds a way to reorganize and establish a new, sustainable balance based on the resources available. By weeks 8 and 9, the jar has settled into a long, stable period dominated by plant life. This is the era of the green takeover. The survivors have established their territories, and the dominant force in the jar is now photosynthesis. The species of algae and maybe some hardy aquatic plants that survived the crash are now flourishing in a controlled, steady manner. They have access to a constant source of sunlight and a recycled supply of nutrients from the decomposers. The inside of the glass may be covered in a thick, lush carpet of green algae, so dense that it can be hard to see through. This carpet of green is the engine of the entire ecosystem. It is constantly producing oxygen, which keeps the water healthy for the few animal species that remain. This process also consumes carbon dioxide, which is released by the breathing of the animals and the ongoing slower decomposition in the sediment. This beautiful exchange of gases is the breath of the jar, a slow, rhythmic pulse of life. The water clarity might be excellent now, as most particles have either been consumed or have settled into the compact layer of mud at the bottom. The jar looks like a serene, green jewel. The animal life has also reached a stable, predictable state. The population of seed shrimp or hardy worms does not explode like the water fleas did at the beginning. Instead, their numbers remain small, limited by the steady but not excessive growth of the algae. They graze on the green carpet, and their waste is recycled, providing a slow and steady trickle of fertilizer for the plants. It is a finely tuned balance. This community is not as exciting or dynamic as the one from the first week, but it is far more resilient. It is built for the long haul, a system that could potentially sustain itself for many more months or even years. This stage demonstrates the concept of a climax community. In nature, after a disturbance like a fire or a flood, ecosystems go through stages of recovery. Eventually, they reach a stable, mature state that changes very little over time. Our jar has done the same. It has weathered a catastrophic population crash and has reorganized itself into a simple, stable, and sustainable form. The species present are the champions of survival, the ones best suited to life in a sealed glass bottle. They are not just surviving, they are thriving in the world they have inherited. As we enter the final weeks leading up to day 100, our jar has become a monument to stability. The dramatic changes are over. The world inside the glass has found its equilibrium, a peaceful state that changes very little from day to day. The thick green layer of algae continues its silent work, bathing the jar's interior in a calming green light. The water remains clear, and the sediment at the bottom is compact and dark, a quiet testament to the turmoil of the past. The jar is no longer a scene of frantic activity or foul decay. It is a place of quiet persistence. The few species of animals that made it through the bottlenecks of starvation and oxygen loss continue their simple existence. The ostracods or worms patrol their small territories, grazing on algae or sifting through the nutrient-rich mud. Their life is predictable. They eat, they reproduce in small numbers, and their waste is recycled. There are no predators to hunt them and no competitors to challenge them. They are the sole inheritors of this small planet. Their movements are the only visible signs of action in an otherwise still-life painting of green algae and clear water. This is the ultimate sustainable community. The processes governing the jar are now in perfect harmony. Every bit of waste is recycled. Every molecule of carbon dioxide breathed out by an animal is absorbed by a plant. Every molecule of oxygen released by a plant is available for an animal to breathe. The sun provides the energy, and the closed loop of nutrients cycles endlessly between the living and the dead, the plants and the animals, the water and the mud. It is a microcosm of the great biogeochemical cycles that govern our own planet, a perfect demonstration of how nothing in nature is ever truly wasted. This final stable state is the ultimate outcome of the experiment. It shows how a chaotic and diverse community, when placed under the stress of limited resources, will eventually simplify itself into a robust and enduring system. The flashiest and most complex organisms may be the first to go, but life itself, in its most fundamental forms, finds a way to continue. The jar has become a living legacy, a quiet world that has weathered a storm and found a lasting peace. Its story is nearly complete and it has much to teach us. The 100th day has arrived. For more than 3 months, this sealed glass jar has been a self-contained world, a silent witness to boom, bust, and recovery. From the outside, it looks peaceful, a vibrant green ecosystem suspended in time. The water is clear, the algal growth is thick, and the dark sediment lies undisturbed. It is time to unseal the jar and take a final look at what has become of the pond water we collected so long ago. As the lid is carefully opened, the air that has been trapped inside for 100 days is released. The smell is the first thing we notice. The foul, rotten egg odor of the great dying is completely gone. In its place is a strong, earthy, and surprisingly fresh scent. It smells like a deep forest after a rain, or a handful of rich, damp soil. It is the smell of healthy plant life and clean, oxygenated water. This pleasant aroma tells us that the ecosystem inside has truly recovered and found its balance. The processes of decay are now happening in harmony with the processes of production, with no nasty byproducts. The air inside is fresh, a testament to the oxygen-producing power of the algae. A closer inspection of the inhabitants reveals the survivors. Using a pipette, we can take a sample of the water and look at it under a microscope. We would likely find the tough little ostracods, the seed shrimp, still swimming about. We would discover a few species of resilient algae, and perhaps some hardy protozoa that survived the crash as dormant cysts. We would not find the delicate water fleas, or any of the more complex insects from day one. The survivors are the specialists, the organisms that were best equipped to handle the dramatic fluctuations in food and oxygen. They are the champions of this 100-day marathon. The sediment at the bottom tells a layered story, like the rings of a tree. The lowest layer is the original pond mud. Above it is a dark, thick band of decomposed matter, the remains of the great dying in weeks 2 and 3. The top layer is a fine, dark silt, the result of the long, stable period of recovery. It is a physical timeline of the jar's history, a geological record of its past. This tiny world has created its own history, its own fossil record, chronicling the rise and fall of its civilizations. The jar is more than just an experiment, it is a time capsule. What have we learned from our 100-day journey with a jar of pond water? We have learned that any ecosystem, no matter how small, is a delicate balance of life and resources. At first, with abundant resources, populations can grow explosively, but this rapid growth is unsustainable. It leads to a crash, as the environment cannot support so many individuals. This is a powerful lesson about limits. No community, whether in a jar or on a planet, can consume its resources without consequence. The boom and bust cycle in our jar is a miniature version of what can happen in any environment. We have also witnessed the incredible power of recycling. Nothing in the jar was truly lost, it was just transformed. The dead algae and animals from the Great Dying became food for bacteria and fungi. These decomposers then released the nutrients back into the water, allowing new life to grow. This illustrates one of the most fundamental principles of nature: the cycle of life, death, and rebirth. Every end is also a beginning. This constant recycling is what allows life on Earth to persist. Our jar shows us that waste is a human concept. In nature, everything is a resource for something else. The experiment reveals the remarkable resilience of life. Even after a catastrophic event that wiped out most of the population, life did not end. It adapted. The species that survived were the ones best suited to the new, harsh conditions. The ecosystem reorganized itself into a simpler, more stable form. This teaches us that life is persistent and creative. It will find a way to continue, even in the most limited of circumstances. The final, peaceful state of the jar is a testament to the endurance and adaptability that is coded into the very fabric of living things. Finally, our world in a jar gives us a new perspective on our own planet. Earth is in many ways just a very large, sealed jar floating in space. We have a limited supply of air, water, and resources. Our sun provides the energy, and the same cycles of production, consumption, and decomposition that we saw in the jar are happening all around us on a global scale. The simple jar of pond water is a powerful metaphor. It reminds us of the delicate balances that sustain our world and the importance of living within our means. This small, green world shows us that by understanding the rules of even the tiniest ecosystems, we can learn how to better care for our own magnificent planetary home.